Guys, you're gonna have to bear with me. The internet at my house is not working super well, so I'm having to record this in my nephew's playroom. So I actually have this propped up on a tiny little toolkit. So let's see how this goes. All right, so last week we talked about how to simplify radicals. So for example, this was one of your examples last week. We had the square root of 24, and we factored 24 out until it was all of the prime factors. And then since you were doing 2 times itself, the square root of anything times itself would just be that number. And we factored it all the way down. What we're going to talk about today is how to do addition and subtraction with those radicals. And it starts very simple. We're going to start with like radicals. What I mean by a like radical is we have 5 times the square root of 2 plus 7 times the square root of 2 minus 6 times the square root of 2. Since every one of them has the square root of 2, that's considered a like radical. It's kind of like having the same variables. Since the radical, in this case the square root of 2, is the same, you can keep the radical and combine the outside numbers. So the square root of 2 is just going to stay exactly the same, and we're only going to combine the outside numbers. So 5 plus 7 minus 6. 5 plus 7 is 12. 12 minus 6 is 6. So this would be my final answer. 6 times the square root of 2. All right, and take it one step farther because that's pretty easy. If you have a mix of radicals, so like right here I have the square root of 7, but here I have the square root of 11, what you can do is you can group the radicals together. What that means is we're going to take the ones that have the same numbers in the radical. So I've got 10 times the square root of 7 plus 4 times the square root of 7. And I can combine those together. I can do 10 plus 4 times the square root of 7. And I get 14. All I did was combine those together. I can also do the same thing with the square root of 11. 5 times the square root of 11 minus 6 times the square root of 11. The square root or the radical is going to stay the same. And then I've just got 5 minus 6. 5 minus 6 is negative 1. But anything times 1 is just itself, so instead of negative 1, we're just going to write minus the square root of 11. Highly recommend pausing this and writing this down. All right, the next part. Woo. Don't look at this yet. Just look at your top practice problems. Yes, it's a picture of a monster. I told you I'm in my nephew's room. All right, I know some of y'all probably saw the answer when I was doing this little transition, but what I want you to do is I want you to look here and here and see if you can go ahead and add them together without help. Pause and do that. All right, perfect. So since all 3 of these terms have the radical the square root of 2, we're going to keep that the same. And then we've just got we've got 3 minus 5 plus 4. 3 minus 5 is negative 2. Negative 2 plus 4 is positive 2. So that's your outside number. Down here, what we did is I'm going to keep the same radicals together. So right here, I've got 4 times the square root of 3. And over here, I've got minus 6 times the square root of 3. So I'm going to combine those. 4 minus 6 is where I get my negative 2. And then the square root of 3 stays the same. My other 2 that are alike, I've got 3 times the square root of 7 plus 3 times the square root of 7. 3 plus 3 is 6, and that's where that 6 came from. All right, you'll have one more video to explain what to do if our radicals are not the same.